Hello, my name is Veronica Carter. I'm sometimes called Coach Carter, and I'm one of the district math coaches here in the county of Henrico, and I'm very excited to be here with you today. Today, we will identify and represent mixed numbers and improper fractions. What is this called? Yes, I do see that it's 5/4, and you're probably saying it's 5/4. Oh, it has a special name. What is that name? Yes, you're correct. An improper fraction. What is this called? That's correct. 1 1/4 is called a mixed number. An improper fraction is greater than or equal to 1 whole. So it represents at least 1 whole. A mixed number is at least 1 whole and a fractional part. What if I tell you that 1 1/4 is equal to 5/4? Yes, they are. Let's prove it. Let's prove it with models through. All right. So we have 1 1/4, 1 whole and a fourth. This is our mixed number, 1 whole and 1/4. Let's look at it as an improper fraction. As an improper fraction, it is partitioned into 4 parts. The whole is still there, it's just partitioned into 4 parts, 4/4 plus the 1/4 you have. So it's 4/4 and 1/4, and that equals 5/4. Let's look at them together. We have 5/4 and 1/4. We have 1 whole and 1/4. They both cover the same area, 1 whole and a fourth. I want you to think of the 5/4 and the whole as a whole pizza. If you had a whole pizza made and it's sitting there, that's a whole. Everyone knows that's a whole. But when you slice it into the parts, you start partitioning into parts, it's still a whole unless pieces are removed. So it's still a whole there, it's just partitioned. And that's the relationship with improper fractions. It is a whole, but it's partitioned. And it had, in this case, it has an extra piece too. All right, and so that's how these two are related. You got it? I think you do. Let's move on. Let's look at a set model to prove this equality here. 3 1/2 equals 7/2. All right, each set has 6 in them to make a whole. So we have 1 whole, 2 wholes, 3 wholes, and then we have a half of a whole, which is this the rectangle on the side with the 3 circles. So you have 3 wholes and 1/2. All right, so let's look at it as a improper fraction. In this case, your wholes have been partitioned into halves. So you have 2 halves to make up a whole right there. So you have 2 halves, 2 more halves, that's 4 halves, 2 more halves, that's 6 halves, and then an additional half, and that's 7 halves. So that's 7 halves. But they also represent 3 wholes and a half. All right, let's look at them together. You still have your 3 wholes and you still have your 2 halves represented here. So 3 wholes and a half, 3 wholes and a half for both, okay? Let's look at our last example, which is we're gonna use a number line to show this equality of 2 1/3 is equal to 7/3. All right, 2 1/3. Notice that the arrow takes you from 0 to the 2, which is the 2 wholes represented. And then an additional third is represented here. So the destination is 2 1/3. On the next one, we have 7/3 represented here. And you have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and then an additional 7/3. And so that's how it is as an improper fraction represented. Let's look at them together and to prove this equality. All right. So together you can see that the whole is also representing 6 halves. So that's going to be 2 wholes, which is also the same as the 6 halves, plus, I'm sorry, not 6 halves, 6/3. The 2 wholes and 6 is the same as 6/3. And then there's an additional third there, okay? All right, I think you have it. Have fun with the practice, representing mixed numbers and improper fractions, and also looking at their equality together. Take care.